Hello dear learners, I welcome you all to the 5th module of this online course on domestic equipment maintenance. Myself, Dr. Kaustubh Bhattacharya, I am working as an assistant professor in the Department of Electronics and Communication Engineering at Assam Don Bosco University. The module 5 has been divided into 4 sessions. The first 2 sessions covered about the microwave oven, and next 2 sessions will be focusing on water purifier. Here in this video, we will explain on the fundamental principle behind the water purification, the basic construction of water purifier, and the types of different water purifier. Now let us introduce water purifier. Water is perhaps the most important nutrient in our diets. In fact, a human adult needs to drink approximately 2 liters, that is 8 glasses of water every day, to replenish the water that is lost from the body through the skin or respiratory tract or through urine. But some water sources cannot safely be used to meet our requirement for drinking water. In fact, 99% of the Earth's water supply is not suitable for usable by human. The unusable water includes salt water, ice, and water vapor in the atmosphere. Only fresh water, which is contained in the rivers, lakes, and underground sources, can be used for human consumption. Furthermore, many freshwater sources are not suitable for human to drink. Many serious diseases such as cholera, diarrhea are caused by drinking water that contains parasitic microorganisms. Water containing large amount of industrial waste or agricultural chemicals, for example pesticides, can also be toxic and unfit for drinking. Hence, humans have a great need for a reliable source of clean, fresh water for drinking. In addition to the water needed for drinking, humans are also using large amount of clean fresh water in other applications. These other uses of fresh water includes household uses like for cooking, cleaning, industrial applications, agricultural, for example irrigation, and recreation. Hence, the quality of the freshwater supply is important for virtually every aspect of our life. Water purification is a process of removing undesirable chemicals, materials, and biological contaminants from the water. The goal of this process is to produce the water fit a drinking for human. Now, water is not really pure H2O. Why it is necessary to treat fresh water before we drink it or use it for the other applications? The answer is that our water supplies are not pure. That is, these supplies contains other species that make the water unsuitable for human use. H2O is certainly the largest and the most important component of any water sources. But this molecule is hardly the only chemical present in the water supply. It may be surprising to learn that water treatment does not eliminate all the impurities from water. In fact, the treatment process itself contributes additional impurities to the water. However, the impurities added during the treatment process generally helps to make water more suitable for human use. Suspended particles typically have diameter in the range of say 1 to 100 nanometer. However, the distinction between a suspension and a solution on the basis of particle size is not well defined. Experimentally, the difference between the types of mixtures is seen using the Tyndall effect, in which the light is scattered by the suspended particles in a suspension. That is, the solution appears cloudy but is not scattered in a homogeneous solution. Example of suspended particles in water samples may include bacteria, floating debris, for example, twigs, bits of leaves and trash, sand and dirt, etc. Types and the amount of these species in a given water samples depends on the source of the sample and what sort of the treatment the water has undergone. Some of these dissolved species, such as oxygen gas, are unavoidable and do not detract from our ability to use the water. Other species, such as ferrite, are desirable and are often added during the water treatment process. Many of the species dissolved in the water, however, are harmful for human to drink or otherwise render the water unsuitable for human use. For example, calcium is responsible for hard water, which can leave insoluble scum on the appliances and industrial boilers. This product must be removed via water treatment facilities. So now, what is the fundamental principle behind a water purifier? The fundamental principle behind a water purifier is to remove contaminants and impurities from the water, making it safe for consumption or various other purposes. Different water purification technologies may be employed to achieve this goal, but they all aim to separate or neutralize harmful substances from the water. One of the most common methods used in household water purifier is the combination of the filtration and purification process. Here, I am going to give a general overview of the fundamental principle. So to start with, the filtration. This process involves passing water through a physical barrier or medium that can tap and remove larger particles and suspended solids. Common filtration media include activated carbon, ceramic filters, and sediment filters. These filters can effectively remove sediments, chlorine, some of the heavy metals, and certain organic components. Then another process is the reverse osmosis, in short, RO process. This reverse osmosis is a process that utilizes a semi-permeable membrane to remove the dissolved solid, ions, or other contaminants from the water. Water is forced through the membrane and only pure water molecules can pass through, leaving behind impurities. Reverse osmosis is highly effective at removing a wide range of contaminants, including bacteria, viruses, heavy metals, fluoride, nitrates, and many others. Then comes another one, ultraviolet sterilization. Ultraviolet water purifier uses ultraviolet light to disinfect water by deactivating and destroying the DNA of the microorganism like bacteria and viruses. Ultraviolet treatment does not remove physical particles or dissolve solids, but it effectively kills the harmful microorganism, making the water safe to drink. Then next is activated carbon absorption. Activated carbon absorption has a porous structure that can attract and absorb certain organic chemical and substances. It can remove chlorine, volatile organic compounds, and some bad taste and odor from the water. Then next is ion exchange. In this method, is commonly used to remove ions like calcium and magnesium from the water, softening it in the process. It involves exchanging of the ions in the water with ions of the same source on a resin or an exchanged medium. Then next is your distillation. Water distillation involves boiling water to produce steam, which is then condensed back into the liquid form. So this process separates the water from contaminants as most impurities have higher boiling points and do not vaporize the water. Different water purifiers may use one or more as a combination of these above mentioned principles to achieve the desired level of water purification. The choice of water purifier depends on the quality of the source water and the specific contaminants that needs to be removed to ensure safe and clean drinking water. Now next comes the basic construction of the water purifier. The basic construction of a water purifier can vary depending on the type of the purification technology that already been mentioned are being used. However, a simple water purifier that combines filtration and purification process typically consists of the following components. The number one, it should have an inlet, also source of the water. This is where untreated water from the source, such as maybe tap or a well, enters the water purifier. Then next comes is the pre-filter. That is the first stage. Usually involves the passing the water through a pre-filter. The pre-filter is designed to remove larger particles and sediment from the water so as to protect them or protecting the main purification components from the damage or clogging. It could be a mesh filter or maybe a ceramic filter or other type of sediment filter. Then next is the main filter, also called the purification medium. The main filter or the purification medium is where the primary purification process takes place. Depending on the technology that used, this could be activated carbon, a reverse osmosis membrane, or maybe an ultraviolet lamp, or maybe other purification materials. The next step could be activated carbon. If the purifier uses, say, activated carbon, the water passes through a bed of activated carbon granules, or it is also called carbon block filter. The carbon absorbs impurities like chlorine, certain organic compounds, and some bad taste and the odors. Next could be reverse osmosis membrane. In a reverse osmosis water purifier, the water is forced through a semi-permeable membrane that effectively removes dissolved salt, minerals, heavy metals, and other contaminants. Next is ultraviolet, or in short UV lamp. A UV water purifier has UV lamp that emits ultraviolet light. Then when water passes by this UV lamp, harmful microorganisms like bacteria, viruses, etc. and maybe protozoa are neutralized and killed. Then comes the post filter, which is also an optional part. Some water purifiers may include or some may not. So this some water purifiers may include an additional post filter after the main purification stage. This filter is used to further enhance the water quality and remove any remaining impurities. Then last, the storage tank. In case where the purified water is not used immediately, a storage tank may be present to hold the water, treated water, until it is needed. The storage tank ensures a constant supply of the clean water even when purifier is not actively purifying. Then next maybe dispensing outlet. So this is the point from which the purified water is dispensed for use. It can be a tap or maybe a nozzle that releases the purified water when activated. Then last, the drainage outlet. Particularly it is for the RO, reverse osmosis system. In the case of reverse osmosis system, there is often a drainage outlet where the wastewater or the rejected impurities are discharged. Not all water entering an RO system is purified, and the rejected water is directed away. So these components are typically housed in a water purifier unit, which may vary in size, design, and complexity based on the specific technology used and the intended application. Say for example, say countertop, under sink, or whole house water purifier. The size of the water purifier construction depends on the level of purification required and the quality of the source water. Then next comes the different commonly available types of water purifier. So there are several commonly available types of water purifiers, such as using different technologies to achieve water purification. So here I have just put some of the most popular types of water purification or water purifier. Number one is the activated carbon filters. These purifiers use activated carbon, as mentioned already. Often it is in the form of granular or in a block form to remove the chlorine, organic compounds, some bad taste and odors from the water. They are relatively simple and effective for say basic water filtration. Then next is the reverse osmosis RO filters or RO purifiers. RO purifiers uses a semi-permeable membrane to remove dissolved solids, ions, heavy metals, bacteria, virus, and any other contaminants from the water. They are highly effective and widely used for treating tap water and the brackish water. Then ultraviolet, in short UV purifier. UV purifiers disinfect water by exposing it to some ultraviolet light, which deactivates and kills harmful microorganisms like bacteria, virus, and protozoa. These UV purifiers do not remove any kind of physical particles or dissolved solids, but are excellent at destroying the say pathogens. Then comes ultrafiltration purifiers. Ultrafiltration purifiers uses a fine membrane to filter out particles, bacteria, and some viruses from the water. While they are not as effective as RO system, they are more cost effective for certain applications. Then next is the gravity-based water purifier. These gravity-based water purifier do not require electricity and operate on the principle of the gravity. They usually contain a combination of ceramic or activated carbon filters to remove the impurities. Then there can be distillation purifiers. Distillation purifiers heat the water to produce steam, which is then condensed back into the liquid form, leaving behind most contaminants. They are effective in removing the wide range of impurities, but can be slow and it's very energy intensive. Then another one is ion exchange filters. These ion exchange purifiers are used primarily for water softening by exchanging calcium and magnesium ions, that is, which cause the water to the hard, that is hardness ions, with sodium ion. They are often used in combination with other filtration method. Then another type is the activated alumina filters. These filters are effective in removing fluoride from the water by absorbing it onto the surface of the activated alumina granules. Then another type is like ceramic filter. Ceramic filters have fine pores that can block the bacteria, that can cysts, sediments, and some larger particles, providing a basic level of filtration. Then there can be like multi-stage water purifier. So many water purifiers combines multiple purification technologies in single unit to ensure comprehensive water treatment. For example, a common say combination is sediment filtration, then say activated carbon filtration, then reverse osmosis, or say ultrafiltration, then a post carbon filtration. Now finally, the size of the water purifier depends on the factors such as the quality of the source water, the specific contaminants that need to be removed, and the budget, the total budget, and the desired level of the water purification. It's essential to consider these factors to select the most appropriate water purifier for your needs. Each of these purification steps or the technologies can be used individually or maybe in combination depending on the specific needs and the level of water quality required. The choice of the water purification method depends on factors such as quality of the source, as I already mentioned, the intended use of the purified water, the availability of the infrastructure, and the budget consideration. Water purification plays a very crucial role in providing clean and safe water to communities and industries, contributing to the public health and the environmental sustainability. So finally, in this video, we have covered the fundamental principle behind the water purification, the basic construction of the water purifier, and the different types of water purifier. So in my next video, we'll explain how to troubleshoot, to do the troubleshooting of various faults in water purifier, and the process how to fix that faults. Also, we'll show how to maintain the water purifier for durable operations. For your further reference, you can go through this link. You will get some detail about the purification process. Thank you. Thank you very much.